Last semester I left it vague. It said, for your image path, just don't let them access arbitrary files. And then I had 1,000 questions in office hours in Piazza asking, what do I have to do to be secure? As long as you're ignoring slashes, I'll be happy with that. Ignore the slashes, then they can't navigate different directories. They should only be able to access files in that images directory that you have. Oh, is that dark? Oh, they closed the shades up here. Do we want it that dark? I feel like we'll fall asleep this early in the morning. But can we read it? Oh, I think I have to just so we can see the slides. All right, so today's examples looks really thin in here today. I know it's midterms week. I'll give them the benefit of the doubt. I said no new content today, just examples. And everybody's working on homework 2, of course. So the combination of all three of those things, yeah, I'm not too surprised. But since we do have a smaller group, I want to welcome you to be more willing to ask questions that are specific to the problems that you're having. If you have any specific questions, I have the chat open, the lecture channel in Discord on my phone as always, and always shoot up your hands. Today's all about examples to help you take what we learned in the past 2 lectures and apply it to your code. So I have a bunch of examples that I'll go through, but I'm flexible. If you have suggestions, something else, even if you do have a homework 2 question, might be able to deviate and talk about homework 2 a bit. I mean, I was just talking about homework 2, so I would say I'll be able to do that as well. Most of you, if you're here, you probably have homework 2 done, or at least almost done. I'm guessing. But all right, so let's go through this. The first 2 examples I want to show is just examples of bitmasking in both Python and JavaScript. So we have these cases where we're getting these WebSocket frames. There are the slides open, just a quick reminder. We have these WebSocket frames, and we have to pull out individual pieces of information from these frames. A lot of that is going to be based on bitmasking. So let's talk about, just briefly, how that works in the 2 most popular languages that y'all are using in the course. So in JavaScript, I'm going to get some byte stream. I just borrowed this from our encodings example. Some byte stream, some data structure full of bytes. And I'm going to pull the very first byte, just print it to the screen, see what it looks like. And then I'm going to create a bit mask. So right here, I have 255, which is going to be 1111, 1111, or FF. So that's my bit mask, which should give me all of the information. And I'm going to take that byte, logical AND it with my mask, or bitwise and I should get the same exact value. So we have 244, and I want to pull up let me arrange my windows a little bit. And see what the bits are for this. Oh, I know. It always wants to switch me to UB Connect. Oops, no, I don't want to connect to Krish's phone. But UB Connect doesn't do anything for me. I need UB Secure. So just to see the bytes in binary, we have 11110000. That was coincidental. I didn't want it to be exactly that. So let's change this to something like 128. 128 in binary is just going to be a 1 in the most significant bit. So if I logical AND it, it's going to zero out all the bits except the most significant bit. And if that bit is 1, which we know it is going to be 1, then ANDing this with the mask is going to be 128. Which it is, of course. So we get 128. And if we want like the least significant 7 bits, like we do for content length, we can do 127. That's going to be 0, then all 1s. And we get, oops, I changed it in Here's a good example of code never lies, comments sometimes lie. If you update code and not your comments. And we get 112. So that's the least significant bits. Least significant 7 bits. We can take that 112, take it over here, and we should see 4 zeros at the end and 3 leading ones. And finally, let's do, geez, I'm blanking on it. Binary to decimal. Let's get the 4 least significant bits. 15. I knew that. Which from what we saw before should give us 0. So this is a way that we can get the bits that we're interested in by using this logical AND. And mostly I just want to show the syntax. The syntax is very similar in most languages, but I want to show the syntax in these 2 languages. Syntax, create an int and AND it with whatever byte you're processing. So if you're processing the first byte from a WebSocket message, get the first byte, AND it with whatever mask you want. Maybe you want to pull the reserved bits, maybe you want to pull the opcode, whatever you want to pull, AND it with the appropriate int for the appropriate bits that you want to extract. This is bitmasking is the keyword for this. So let's jump over to Python. See the same thing. I'm going to create my, my byte just directly this time, just because I feel like doing things different in Python. And then AND it with, let me get a variable here. AND it with my mask. So if I have the byte FF, I'm going to get the first value here, the first byte, which is going to be all ones, 255. And I'm going to AND it with my mask. Let me print out the, just to make it look like the JavaScript example. Python 3, bitmask, py. So we get 255 when we print out the byte. And when we AND it with 8, we're going to get 8. This byte is all ones, so whatever we mask it with, we expect to get that directly back. If we change this to F0, that's going to give us the same byte that we were playing with in JavaScript. And then we're going to AND it with 8. We should expect 0 now, because that bit is now 0. We have 1, 1, 1, 1, 1, 1, 1, 1, 1, 0, 0, 0, 0. So we AND it with 8. 8 is going to be 0, 0, 0, 0, 1, 2, 1, oops, 1, 0, 0, 0. So we're going to mask out this bit. If we want to do something like, I don't know why I challenge my brain like this, 32, I'm just going to do it this way so I don't have to think. If we want to do these 3 bits, we'll get just these 2, which would be our 48. Our 32 plus 16, we got these 2 bits. These 2 were zeroed out. This 1 didn't get anything, so it's just 1, 1, 0, 0, 0, 0. So this is how we can do some bit masking. It's relying on the fact that integers are represented in binary in the computer, in the machine. So even though we think of these as decimal numbers, they are actually binary representations when they're stored in the computer. So we take advantage of that fact and pick our ints carefully, or you can straight up do the hex or straight up binary if you don't want to think about the convergence from decimal to binary. But even if you use straight ints, they're still going to work the same way because they are represented as binary, as you know from other classes, of course. But this is where it's actually going to be right in your face, like, no, you have to be aware of this while you're coding, because you can take advantage of that fact to mask out the exact bits that you want. Might as well do my math. Hey, wait. I shouldn't have went for it. 48, 32, 16. Oh, maybe I am off. All right, is this working the way we want it to? I just want to double check to make sure I'm not doing anything silly. This would be 40, 56 would be all of them. So I'm getting these two bits. 1, 2, 4, 8, 16, 32. Oh, we're getting 48 from that.
It's 16 plus.
Yeah, I think, yeah, I'm thinking about it now. I think I'm just being silly about it. Yeah, I shouldn't try to do math live. I got too much stuff going on in my brain, thinking about the next example and everything. I can't even add 32 and 16 right now. So this would be 40. So I meant to do 56. This is 56. I did that math wrong. Oh, geez. All right, and then we get 48. All right, everything's working. The example works. So any questions about bit masking and working at the bit level, at least in these two languages? So I want to expose some syntax and show you how what you learned in other classes you actually can play with them in whatever language you have. Yeah.
Is there any other bit operations other than like XOR that'd be useful to use for our purposes, or not really? Just and an XOR should be good.
And an XOR should be good. By the way, XOR is usually the caret. So we get 1 1 0 0 1 0 0 0, which I'm not going to embarrass myself doing math again, but that should be 200. So XOR, logical and, I think those are the only two that you'll really find useful for these homeworks. It's the same thing. Oops. The syntax is pretty standardized across languages. So we'll get, I don't want to run through that, but it'll be logical XOR as the caret in pretty much any programming language. Anyone that I've come across. I say pretty much just to hedge my bets, because someone will be like, well, in this really obscure language, it's not. Yeah, I'm sure. But most mainstream languages, it's going to be the caret and single ampersand for logical and. Oh, maybe bit shifts, actually. I take that back. So say I want to filter the most significant bit here. I'm going to AND it. And that gives me 240 for some reason. And 255. Oh, I wanted 128. I want to just check the most significant bit, right? And I get 128. And maybe I don't want to check, is it 128? I really just want to know, is that bit 1 or 0? So what we can do here is shift it. This is the most significant bit, so I'm going to do a logical shift, everything's backwards, shift right by 7 bits. And it's going to give me a 1 or a 0. So that bit was 1 because I wanted to mask the most significant bit, which is the 8th bit. So I'm going to do a logical shift right by 7 bits. And now it's either going to be 1 or 0, whether that bit was 1 or 0. So that one might be useful as well. And then you can write generic code like function check bit. Check the bit at value n, and then say mask equals I remember the syntax. Pow, there it is. 2 to the n. Right to check. const x. I don't know. I can't think of a better name right now. Byte to check ampersand mask. I'm missing my semicolons to, and then return x shift by n. Is that right? N minus 1.
Then minus 10 even.
Yep. Thanks. And then console.log. And I want to check the 8th bit. Right? Is that going to get me where I want to go? I never called my function. I should never go off script this far. Two to the 8. I think this needs to be minus 1. Oh, and I have minus 10 here. Jeez. I want to check the 8th bit. N minus 1. That's going to give me 128. And then shift. I'm going to shift by 7. Yeah, this should work, but I might call it just because I don't feel like sitting here debugging. Wow. That should be a comma. There we go. I was using a bitwise XOR operation there instead of, anyway. But so you can write a function like this. You know, you can write helper functions that if you want to check individual bits. I don't know how useful this would be in the homework, but just as a, just as an example of using multiple bitwise operations in your code, we're using, and actually this can be replaced. This. So we can do a bitwise shift left to take 1 and shift it left n minus 1 times, and then that's going to give us our power of 2. We're going to be multiplied by 2 every time. All stuff that should be fairly familiar from other classes, but you probably haven't seen it in code based on just the quick question that I asked last time. I wish them classes would show you code, and even have programming assignments where you do bitwise stuff. I think it'd really solidify the concepts. But you get practice right now, so problem solved. All right, any other questions about bit operations? Any other examples you want to see? Okay. Jump into WebSocket Frames. I have the server running because last time I didn't have the server running. It took me like a minute to get it up, so to get it running. So it's already running. I have my page here. And whenever I double check what's happening, whenever I send a frame, I'm going to send this to the chat. Oh, things aren't working here. Let me restart it anyway. Listening on port 8000, refresh. I can see my request for regular stuff. Here's, oh, I want to talk about that one. Like get messages is going to return nothing. My request for /socket, connection upgrade to WebSockets, and my WebSocket key. And I'm going to respond with the appropriate response, which I'm not printing to the screen. And then once that WebSocket connection is made, actually I want to open up the console. Refresh. Look for the 101. I respond with the accept. And then once we have a WebSocket connection, you can go into your browser, go into this network tab and click messages on the WebSocket request. And it's going to show you all the WebSocket messages that are going back and forth. So if I chat something, that undefined has me a little nervous, but okay. I'm sending a message that's going to send my username and message, just like for the homework. And the server is responding with the username and message. So I don't have code on the front end that's going to say, when I'm sending a message, by the way, render that to the HTML for me. I'm sending it to the server, and then the server is broadcasting to all users the message that I have. So once the server responds, that's when I'm going to render it to the page. Just the way I have it set up. It can be set up different ways. But that's how I'm working here. So I send a WebSocket frame, and I receive a WebSocket frame from the server. So let's go to the server and take a look at the structure of these WebSocket frames. So here's the frame that I received. And we can start looking at the bytes. This is something I strongly recommend as like the first thing you do when it comes to WebSockets. I can't really show the code, can I? Is having it print in a way that's readable, that's very similar to the way that we see the WebSocket frames in the slides and in the spec. So in the slides, we're used to seeing it like this, where it's 4 bytes wide, 4 bytes per line. So I wrote some code to have it print 4 bytes per line, and then separate them with underscores to be able to have them printed in a way that I'm used to seeing from the spec. It takes a little bit of work to get things printed like this. Most languages, when you print out bytes in binary, they want to remove the leading zeros. So I have some extra code that adds in the leading zeros. I check the length of the string that's going to be printed, and then prepend as many leading zeros as I want to be able to get to, that I need, to be able to get to 8 total length. So it takes a while to get to this, but it helps significantly in reading things, debugging things, getting examples of web frames. Like having this example of a web frame is really nice to have, that I can just see it. I can look at it, make sure that I'm getting the frame in the right format, the format that I expect, I should say, that you expect, parsing through it manually, and then double checking, okay, why isn't my code doing the same thing? So let's take a look at this WebSocket frame. The first byte, 100000001. Under the assumptions of the assignment, you can always assume this first byte will be exactly this. So that's the first thing. I'm seeing that exact byte as the first byte. It's giving me a little more confidence that things are working the way I expect them to be working. This is the finish bit. The finish bit is 1. The 3 reserve bits are 0. And the opcode is 0001, which means the content of the frame is text. Next, we have our mask bit. Next, we have our mask bit. That's set to 1, so we know that there's a mask. And it's always going to be set to 1 when the client is sending messages to the server. That's going to be 1. And then the next 7 bits is my payload length. So if I grab this payload length, let's go to our conversion here. I'm going to go the other way. We have a payload length of 41. So since that's not 127 or 128, I know that that's my entire payload length. I know that this is my mask, my 4 bytes for my mask, and then the rest of the information is the actual payload. And we should expect 41 bytes of payload here. So if we count these bytes, we have 5, 1, 2, 3, 4, 5, 6, 7, 8, 9 times 4, which is 30, anyway, geez, 36, 37, 38, 39, 40, 41. So we have exactly 41 bytes of payload. So again, we're feeling more confident. We're double checking what we understand about WebSocket frames and looking at an actual WebSocket frame sent by a modern browser and double checking, making sure everything works. So we have 41 bytes of payload, or not making sure everything works, but making sure you're understanding the structure of these WebSocket frames. I'm feeling good because I have 41 bytes of payload that of data that I expect to be the payload. I have 4 bytes of the mask, and this payload length is exactly 41. So everything's checking out, feeling good, feeling pretty good about this. If we get a WebSocket frame, how do I do this? Character counter. And get something that's greater than 128. So I want to get a longer message here. I'm going to send this. And now we expect something a little bit different. And you know I'm not going to go through and count all those bytes this time. But I received a WebSocket frame that's going to be quite a bit longer than what we saw before. Actually, I'm not going to count them, but I have the count right here, 208. We expect the payload length to be 208. Those are all ASCII characters, so 1 byte per character. I can use the character count in this case. So I expect this to be a payload length of 208, and there's all my bytes. So if I look at this WebSocket frame, I get exactly 126 is the payload length this time. Exactly 126. This is telling me that the next 2 bytes are going to be the actual payload length, because this payload length couldn't fit in 7 bits. We needed at least an eighth, only an eighth in this case, an 8th bit. If we go to our converter here, we should see that 208, 244. Oh yeah, 244 because I'm adding username in the JSON formatting. Forgot about that stuff. So we get a few more. We get extra bytes for my JSON overhead. But we get something ballpark that we expect. I'm not going to go through and count all these. Maybe I will. Maybe. And then the 4 byte mask. And then, no, I'm not going to. It is divisible by 4. Maybe we will. Just to verify. So this, I'm going to cheat and just paste it up here. We have 61 times 4. Why do I even try to do math? I can never do math on the spot. 61 times 4, what is it?
244.
244? I could have just, I know it's going to work out, so I could have just said 244 because I had it here. I could have just been like, that's 244, and pretended I did the math and verified everything. Because I know it's going to work out. But 244. So we're verified that, again, everything's working the way we expect it to. We're not going to send messages where this is all ones because that's just a lot for this example. But let's go back down to a smaller example and start handling this mask. Let's just go down to, does my server do empty strings? No, I prevent empty strings. Let's just send a space. So we expect, if we're just looking at the first 4 bytes, we're going to get the open brace. Let me try to highlight it. Open brace, quote, US. Oops. So let's look at what bytes we're going to expect. Convert to ASCII. Fine. So let's get to our right frame. So here's our bit mask. And then we're going to XOR that with each 4 bytes of the payload. Very painstakingly. So here's the first byte of payload. We're going to XOR it with this byte. So that's going to give us 0, 1, 1, 1, 1, 0, 1, 1. The next byte, we're going to XOR this byte with this byte of the mask. 0, 0, 1, 0, 0, 0, 1, 0. This byte with this byte. 0, 1, 1, 1, 0, 1, 0, 1. And finally, this byte with this byte, which is going to be, oh my eyes, 1, 1, 1, 0, 0, 1, 1. So here's our first 4 bytes. If we take these bytes, maybe I can use that first calculator. Line string to ASCII. Oh yeah, that's not what I want. Hey, and then we can see that those are the ASCII bytes for the characters that we have. Then we can keep going through XOR each 4 bytes with the mask, and then finally get back to our original message, the message that we're trying to read. So that's how to do all of this stuff. Of course, the next challenge is actually doing everything that I did manually and automating it in code. That's what you need to do for the homework. How do you code all of this? Take your understanding of WebSocket frames, WebSocket connections, automate the whole thing, and have it run in a web server. And of course, that's the part that I'm not going to show you. And the last thing is when you send the WebSocket frame back, it's going to be very similar, except your masking bit is 0, and there is no mask. So the masking bit 0, our payload length fits in 7 bits, because this is not mostly ones, roughly. And then our payload starts right here, unmasked. And you can see the leading bit is 0 every single time. It's unmasked ASCII. We would expect the most significant bit to always be 0, because that's true for ASCII. So as a kind of quick sanity check, we can see that that's unmasked ASCII. And the first 4 bytes should match what we have here. Any questions about any of this? And if you're not at the point where you're confident you can code all this up, you should have some question for me, right? Anybody have questions? Yes.
Just on, so once the WebSocket's opened, if like you were to, like another user were to input, the previous WebSocket would know to send the other user's input?
Ooh, can you rephrase that? I thought of something important that I want to say based on that. I want to see if that was your actual question.
Without like, it's WebSockets is supposed to be like, you're not supposed to need to refresh, right? So in this scenario, are the 2 WebSockets communicating with each other? Like if you open like another user, for example, right? And then user sends message. Does it also say, okay, all other sockets, here's a message, or is it sending it, or do you need to refresh?
You definitely don't need to refresh. That's our main feature that we want from WebSockets. But like if I send, they're going to see it right away. The WebSockets are not communicating with each other, but both browsers, both windows here, are talking to my server. And I have my server coded to whenever the server receives a WebSocket frame, it's going to parse it, do its thing, and then send the WebSocket frame with that information to all connected users. Okay. So there's a few tricks here. These are the last things I want to talk about, is how do you remember who's connected? Like, who are you sending these things to? So this offers some different challenges depending on your language, but it's helpful to remember a list of everybody who's connected and store a reference to the socket connection of everybody who is connected. So and this is code that I commented out for one of my earlier examples, but like in JavaScript, you can read from the socket and get the address and port for a specific user. The address, which is the host, and the port is going to uniquely identify a user. So you take those two pieces of information, concatenate them, and remember that as the client ID, and then I'm going to store that client with that ID, and then if I see another message from that same exact client, it's going to give me some information. I'm going to say, I saw this client before. Where this is really needed is every time you receive data from the stream, from a TCP socket in JavaScript and Node, this function is called. So the first big question you need to ask whenever you receive information over a socket is this an HTTP connection or is this a WebSocket connection? Because you're going to handle them very differently based on what type of connection it is. So you have to remember who has been upgraded to a WebSocket connection. So if you have some way of uniquely identifying them, you get the socket, the /socket request, you upgrade them to a WebSocket connection, you have to remember that when I see this client again, don't try to parse the request line and the path and the headers because you're getting a WebSocket frame which isn't following HTTP protocol. So all your parsers are going to crash. Everything's going to crash and burn at that point. So you have to remember this is a WebSocket connection. And then when you get, and then storing the socket for each one of them, when you get a WebSocket frame, going to each one of those sockets and saying, hey, here's the new message. This also implies that you need concurrency because you're going to have multiple WebSocket connections, multiple TCP connections open that are remaining open, that are persisting. So you need good concurrency here, or concurrency at all. For JavaScript, for Node, that's easy. It just does it automatically. It's actually hard to write JavaScript code that's not concurrent. If you want something to run synchronously, it's actually, there's some extra steps you have to do. JavaScript was built from the ground up with concurrency in mind. So concurrency, solved. Solved already for JavaScript. For Python, things are a little bit different. You can get the client address. 0 and 1 is going to give us the same information in this data structure. So you can remember this client. And then you have to remember all of the clients as either, there's one case where maybe you want to go all the way up to a global variable, but you have to know all of the clients across all connections. So in Python, this handle method is called once per TCP connection. So you're going to be in some while true. This is where while true comes in, is if you have a WebSocket connection, you just want to you're just going to keep reading from that connection. This is like, we got a WebSocket connection request, and then enter the while true, and then keep reading from the TCP stream. This is where the max frame size, we're going to have 1K. That's where that comes in. So you can just do this, receive at most 1K bytes, and then handle that as a WebSocket frame, and then go right back here and wait for the next WebSocket frame, wait for the next chat message from this user. But you do have to remember, somewhat globally, all of the clients that are currently WebSocket connections. So when you do receive a frame, you can broadcast to all of those sockets. This self is going to be a reference to their socket. Add all those selves to a data structure. Like here, I'm only storing the address of the client, but you would want to store the socket itself to the client. So you can do socket dot send all. So you can do the send all for each one of those sockets. So there are little tricks in each language now that we have multiple connections open at the same time. I'm glad you asked that because I almost forgot to talk about that part. Yeah.
So when do you, you have users connect and they're like, okay, I added the client. Let's say one of the users disconnects. When do you know to remove a client from their client? So
we're not going to handle disconnects. You can, I didn't add this to the homework, but when the opcode is 1000, that's when a client is closing the connection, and that's when you would remove them, when you see that opcode. But with my assumptions, I'm not going to change my assumptions now. If I close this, I'm not going to change my assumptions this, after the assignment's released. But if I close that, I'm going to see an opcode of 1000. So that means that client is requesting to close the connection. And then I would go through all my data structures and remove that client and break the well true. If I see that break, get out of that loop, end that connection. Next semester, I'll have to add that. This semester, I don't know how we would test that. The testing procedure is tough too. It would just hold me back from doing that. But that's how you would do it if you do want to add that to your homework.
You have everyone have to check the client's global variable.
Yeah, and how are we going to do that? We can do that, but do we run it in the debugger? Plus, especially when it's multi-threaded, everything, it's messy. We don't have a good way of verifying that connection's been severed, or that you're out of your well true loop, or removed from your data structures in Node. It's a hard one to test, unfortunately. But if you want to add that, I would be happy about it. But it's a hard one to require, just logistically. Or else I'll double the time it takes to grade these things, just with that one objective.
I was curious. So for buffers, I noticed that, I don't know if this is something I missed, but when it would overflow, right? And I needed a buffer, it would send first only the header and no extra content. So it would always be less than my max amount I'm receiving. I have a 224, and it would send just the header and then the content. Is that?
Yeah, it's common. We talked about that a few times. Yeah, that happens a lot. Especially, I think it's more often in Chrome. I think Chrome likes to do that a lot because Chrome's trying to optimize every last nanosecond that it can.
Right.
So it's I got the headers ready, here you go. And then it's getting the data from the form and then sending that, a few milliseconds later. But that's long enough for your code to say, oh, there's information to read off the TCP stream. Here you go, here's that information. And then by the time you get back to where you're reading from the stream again, then the rest of the information's there. But there's just enough of delay that you're getting just the headers first.
So you shouldn't always, though it could depend on the browser. So you could
yeah, it depends on the browser. The only assumption you can make in this course is that the first read, you're going to get all of the headers.
Okay. But there's still, there's a possibility depending on the browser, you would also get some content. Some data.
Yeah, you might get some content, you might get all the content, you might get no content. Okay. But you'll get the headers. I haven't seen a case yet where you didn't get all of the headers.
Right.
So I'll say that's a safe assumption. And if you run into a case where you're not, especially during grading, I can regrade that one. Because that's a safe assumption for this course. Not all the time. Headers can get pretty big, so it's not always. You could have more than 1K of headers. And my code I just showed would break on that if I was coded under that assumption. But you can safely assume that for this course. No, go ahead. I was going to ask if there are more questions.
Is there any other part of the header? Because I noticed that there's a lot of information on the headers. Is there anything else that we would possibly need to parse from out of there? In the real world, yeah. For this course, you might be interested in a lot of other things, like reading the. I don't have a good example off the top of my head, but there's I do have a good example off the top of my head. So, oops, I was already in there. Find an HTTP request. You might want to read this user agent. This is saying that I have an Intel Mac. So if you have a download page where you have a Windows, a Mac, and a Linux version of your app, I might want to read that and then take you to the specific one for your operating system. If you notice you ever go to a download page like that, it always takes you to your operating system. It's not just because you have the most popular, the favorite operating system of those developers. Just means they read your content link, or not content link, user agent, figured out what operating system you have, and then took you to the right page. If that's the case. For mobile, what is the? I'm assuming that says it's not mobile. The question mark 0. But is that if it was 1, it would mean it's mobile?
I don't know. I don't know what that one exactly. I don't know enough to give you a firm answer on that one. I don't know if I've seen that before. Maybe that's something that Opera GX sets. Maybe it's just something newer that I haven't seen before. The languages, accept languages, you might want to read that as well. If somebody says, I don't speak English, you don't want to send them the English version of your page. So just all the information, whatever you have. The refer is nice to know. Was this a link from another page that somebody clicked and navigated to me? Then I might say like, hey, welcome from Facebook, or at least log that in my database for some tracking information if I want to use that information for something. So there's lots of good information in here.
And what is accepted encoding?
Those are the encodings that this browser is going to speak. gzip, deflate, and BR. To be honest, I don't know exactly what that. Why gzip, deflate, and BR? I've seen that all the time. I never actually looked at it long enough to think about it. Yeah, I don't have a good answer for you. Sorry. And on that, let's end on that note of me not being able to answer a question. See everyone. What day is it? Friday? Yeah. See everyone Monday. Have a great weekend.